Greetings. In my last video, I measured a roller jewel gap, and I was puzzled by the different measurements I got from my eyepiece reticle versus my roller jewel gauge. I asked for viewer suggestions, and I was gratified by all the responses that I got. Earl Sterling suggested that I should confirm the thickness of the gauges and wondered about the accuracy of the microscope's magnification. JMC Keith MD suggested that I should measure the gauges directly with the reticle. Mercurial 2810, my friend Mark from Australia, suggested that I should look at microscope runout as an error source. Sam Bros 1 suggested that I calibrate the reticle against a known size reference so that they're the same apparent length, and then check it against another object. Sean SEO Eltoir also suggested measuring the gauge with the reticle, wondered about oxidation on the gauge's surfaces, and about whether the gauges were positioned straight on against the gap when I did the measurements. User Kevin D 4830 pondered the differences between fitting into something and measuring width. He prodded me to read up on fits and tolerances. Getting all this help shows how great the web can be when it doesn't suck, which, let's face it, it does most of the time. I've learned a lot from looking into each of these suggestions, and I've arrived at a satisfactory explanation for what was going on with my measuring a 0.52 millimeter distance versus a 0.56 millimeter distance for the roller jewel gap. The gauge surfaces were clean. They might have microscopic oxidation or grime, but if so, it's not visible to my eyes. And in fact, I chose this set over others that were for sale on eBay because of how clean they were. In any event, I measured the gauges with digital calipers and they were spot on. So unless I want to hypothesize that my calibers are also bad, I have to conclude the gauges are correct. I examined the possibility of slop in the microscope's mechanics. I dialed in a magnification from below, took measurements, and then repeated the exercise dialing in from above. I tried wiggling the magnification knob before dialing in a setting versus going straight to that setting. I didn't detect any runout. This surprised me a little, to be honest. I know I bought a quality scope at that price point that I was able to afford, but it was still pretty nice to see how tight it was as a piece of mechanics. I edited down my microscope work in the last video, so you didn't get to see all of the attempts I made to fit the gauges into the gap. I did wiggle the gauges around a bit, and I did try half of them twice to ensure that I was entering the gap straight on. I didn't try to force the gauges in, if for no other reason than the pallet lever was mounted on the plate, and I didn't want to stress and possibly break its pivots. And my reticle measurements of the gap were also spot on as far as I could tell. I did watch for parallax. There's a source of error here, but I'm not sure how to quantify it. Locating the edge of something has a subtle consideration. If an object contains a 90-degree angle, you may think it's a, precise right angle, but it really isn't. If you use a sufficiently high magnification, you'll see a rounded corner. I don't think this contributed to the error I saw, but I'm mentioning it for completeness. I measured two of the gauges with the reticle, and here's where I found two error sources. Using my calibration table, I measured the 0.60 millimeter and 0.50 millimeter gauges with the reticle at 20x and 45x magnification, i.e. the zoom knob was set at 2 and then pegged to the maximum. There's a source of error that can happen at intermediate points on the zoom knob, that is, at any point between the minimum and the maximum stops. It wasn't a source of error in my gap measurement because I did that at the maximum stop, which was about 45x magnification. When you set the zoom knob at any intermediate point, the 1.5 mark, the 2 mark, or what have you, you're setting it at a line marked on the dial. Well, that white line has a thickness. Now you may think your alignment is spot on, but it might not be. You could be slightly off. And unless there's slop in your scope's gear train, which if there is, that's a bigger problem, That will translate into a different internal lens position. But for the other error source, which I think did happen here, let's consider the margin of error in visual measurements. Look at these results. Using the reticle, I'm off by fractions of hash marks, because seeing that an object extends 1/5 of the way into the next hash mark gap is a tough call. It depends in part on how the other end of the object is aligned on the reticle scale, which is another tough call. Can I see the difference between 0.2, 0.25, and 0.3 hash mark gaps? Well, maybe. But given the relative scales here, this can be a catastrophic error in watch repair work. Imagine concluding that a replacement part should be 0.59 millimeters long instead of 0.6, or 1.24 instead of 1.26. That amount of error matters a huge amount in watchmaker work. Now, I had suspected something like this in the previous video, but I hadn't reached a conclusion. Well, I now conclude that this reticle scale is incompatible with the distances that I'm measuring for the work I'm doing. I need a reticle with at least 100 times the number of hash marks, as well as a way to visually discriminate between them, for the reticle method to not have this error source. But this is about a 2% error, and I was seeing a 7.5% error. Where's the rest of it? I think the majority of the error can be attributed to my ignorance of fits and tolerances. And for this insight, I thank Kevin D. 4830. He wins the Old Guy Career Change Channel Grand Prize. My eternal gratitude. I'll cut to the chase. An object with width x will not fit into a gap of width x. This subject is a rabbit hole that I went only a little ways into. The width of the inserted object must be less than the gap. The magnitude of how much less depends on what kind of fit the object needs. There's an entire science around categorizing and quantifying and understanding fits between two parts that I only scratched the surface of in researching and understanding my measurement error. This is a real consideration in the mechanical mating of any two object surfaces. It so happens that there are YouTube videos about this, of course. They get into manufacturing processes and mechanical engineering. Now, this is a huge topic with a lot of science and engineering behind it, and I have inadvertently face-planted right into it, publicly. Getting back to my problem, even if the reticle measurement had 0 error, it's possible for it and the gauge to be different, that is, to return different values, and they will both be correct for what they're measuring. The reticle is measuring the gap's apparent width, but the gauge measures what size object will fit into the gap with the desired amount of wiggle room. It must be less than the gap's width, even without leaving room for shellac, and even if we were going for a tight press fit. So the gauge, in fact, is the right tool to measure the jewel gap. Now, I'm still thrilled to have the Microsoft reticle. It'll still come handy in other applications, but for measuring what width object is needed to fit into another object, it's the wrong tool to use. Summing up, I've ordered my 0.50 millimeter long roller jewel from Dave's Watch Parts. He's a great source of information, supplies, and tools. If you don't know about him, I encourage you to visit his website. He's not sponsoring me to say this, and haven't been paid to say this. I'm saying it because he's a great resource, and you should check him out. And an update on my WTI application. I won't hear whether I've been accepted until the end of the month or possibly early March. And I'm trying not to think about it in the meantime. That's all I have for you today. Till next time, take care.